Hello everyone, good evening. Today we are discussing about our project Intrusion Detection Systems IDS using machine learning. The team members are myself, Vishwadatta Gudapati, Surateja Merugu, Nitin Sampath, Rohan Bhimavarapu, and Naga Jagadishwari Kari. Coming into the project details, the first thing is introduction to IDS. So, what is an intrusion detection system? IDS. So, an intrusion detection system is a security application that monitors networks or systems for malicious activity or policy violations. It is designed to identify potential security threats and generate alarms to warn administrators of suspicious activity. So, the key features of IDS are real-time monitoring, notification system, alerting, customizable alerts, immediate response as logging, and reporting to the manager, etc. So IDS can be network-based NIDS or host-based HIDS. And going deeper into the importance of IDS, the first thing is security, protects against unauthorized access and attacks, as it has constant vigilance. As IDS continuously analyze network traffic and system activities, immediate detection, threats are identified as they occur, allowing for timely response and proactive defense. By detecting threats in real time, IDS can prevent potential damage. And the second thing is monitoring. It continuously analyzes the network traffic. And the third thing is detection. It identifies the potential threats in real time. It gives immediate response like timely alerts and enables swift actions to mitigate threats and customizable alerts as well. Alerts can be tailored based on the severity, threat type, or other criteria. And the compliance help meets regularity and compliance requirements. Is logging the IDs records networking and system activities for later analysis. The audit trails as well. The logs provide evidence of security incidents and compliance adherence. And coming to the next part, it's types of IDs. There are three types: signature-based IDs, anomaly-based IDs, and hybrid IDs. The first thing is signature-based IDs. It detects known threats using predefined patterns or signatures. So how it works is it compares incoming network traffic or system activity against a database of known attack signatures. If a match is found, an alert is generated. So the advantages of this IDS is it has high detection rate for known threats and low false positive rate. And the next one is anomaly-based IDS. Anomaly-based IDS identifies the deviations from normal behavior with a network or system. So it establishes a baseline of normal network or system activity and flags any significant deviations as potential threats. So this advantage of this IDS is it can detect unknown or zero-day attacks, adapts to the changing network behavior. And the last one is hybrid IDS. It combines signature and anomaly-based methods for improved detection. It works as it leverages the strength of both approaches to detect unknown threats and identify potential new threats. The advantage of this one is it provides comprehensive protection against both known and unknown threats and also reduces the false positive rates compared to the pure anomaly-based systems. From here, my friend Suryateja Merugu will continue.
Role of machine learning in intrusion detection systems enhances detection capabilities by identifying patterns and anomalies. Pattern recognition trains on network traffic and user behavior to identify deviations. Anomaly detection establishes a baseline of normal behavior to detect outliers like unusual login times and abnormal data transfers. Learns from historical data to improve accuracy over time. Training and retraining continuously improves by learning from historical data. Incremental learning updates predictions with new data, adapting to emerging threats. Future engineering identify key data attributes to enhance intrusion detection accuracy. Reduces false positives and improves response time. Enhanced classification distinguishes between good and malicious activities with greater precision. Contextual understanding considers activity context to make informed decisions. Automated filtering cross-reference activities to reduce false positives, easing the burden on analysts. Rapid responses provides real-time alerts and quicker remediations, minimizing breach impact. Now let us see common machine learning algorithms in intrusion detection systems. Decision trees. The overview of this is simple and powerful for classification and regression by splitting data into subsets. The advantages of it is easy to understand and interpret, and it handles numerical and categorical data with little pre-processing. Random forest ensembles method combining multiple decision trees for improved accuracy and robustness. The advantages of random forests are reduces overfitting risk, higher accuracy and stability, and it handles large high-dimensional datasets. Support vector machines, SVM. The overview of this is supervised learning model finding the best hyperplane to separate data in high-dimensional space. Coming to the advantages, effective in high-dimensional spaces, robust to overfittings, support linear and nonlinear classifications. Neural networks. Algorithm modeled after the human brain recognized patterns and interpreting sensory data. The advantages of neural networks are model complex models, nonlinear relationships, learns and generalizes from large data amounts, suitable for supervised and unsupervised tasks. Coming to the next slide, pre-processing steps for machine learning. Data cleaning. The objective for this is to ensure the quality and integrity of the data. The steps involved removing duplicates and handling missing values. And coming to the importance of data cleaning, clean data is essential for building accurate and reliable machine learning models. The next one is normalization. The objective for normalization is to ensure consistency across features by scaling them to a common range. And the steps involved are min-max scaling and z-score normalization. And the importance of normalization is it helps in improving the convergence speed of learning algorithms and ensure that each feature contributes equally to the model. Feature selection. It improves model performance by identifying and selecting the most relevant features. The steps involved are filter methods, wrapper methods, and embedded methods. Coming to the importance, it reduces dimensionality, enhances model performance, decreases overfitting risk, and reduces training time. Label encoding. It converts categorical label into numerical format and uses in machine learning models. The steps involved: ordinal encoding, one-hot encoding. And the importance for label encoding are necessary for algorithms that require numerical inputs, ensuring that the categorical data is accurately represented and understood by the model. Coming to the next slide, techniques of handling imbalanced data. Uh, Resampling, oversample majority classes or undersample majority classes. SMOTE, synthetic minority oversampling techniques. It generates synthetic samples to balance classes. Algorithm adjustments. Modify algorithms to account for imbalanced data.
Hi, as my friend has explained about techniques of handling imbalanced data, I'm going to explain how we have trained our machine learning models. So, to ensure that our machine learning model generalizes well to unseen data, we begin by splitting our dataset into two distinct sets, the training set and the testing set. Typically, this is done by using an 80 by 20 split, where 80% of the data is used for training the model and 20% is reserved for the testing its performance. The training set, that is the 80%, this subset is used to train the model, allowing it to learn from the patterns and relationships within the data. The model adjusts its parameters to minimize the error on the set. Testing set of the 20%, this subset is kept separate and is used to evaluate the model's performance. By testing on unseen data, we can access how well the model generalizes to new real-world data. Using cross-validation to validate model performance. So we have used cross-validation to validate the model performance, and the cross-validation is a technique used to assess how the result of a statistical analysis will generalize to an independent dataset. It involves partitioning the data into several subsets or folds. The model is trained on some of these folds and tested on the remaining fold. This process is repeated multiple times, with each fold serving as the testing set once. Steps in cross-validation are dividing the data, training and testing the data, and evaluating the data. So we have trained models using selected algorithms and fine-tuned hyperparameters. Now coming to the evaluation of model performance, there are three main parameters that we check, that is accuracy, precision, and recall. For the accuracy, it is the overall effectiveness. We can define it as the performance of correctly classified instances out of the total instances. So the formula would be true positives plus true negatives whole divided by total instances. So the use case can be it can be useful when the classes are balanced. So when it comes to precision, the proportion of the true positive instances among all the instances predicted as positive. So the formula would be true positives by true positives plus false positives. And the use case is when it is critical when the cost of the false positives is really high. And when it comes to recall, it is for the sensitivity or true positive rate. It can be defined as the proportion of true positives instances among all the actual positive instances. So the formula would be true positives divided by true positives plus false negatives. And the use case is it is important when the cost of the false negatives is really high. And the F1 score, it is the harmonic mean of precision and recall, providing a balance between the two. So the formula would be F1 score is equal to 2 into precision multiplied by recall divided by precision plus recall. And the use case is useful. It is really useful when you need a balance between precision and recall. Now let's take a look at decision tree classifier. A brief description can be: a decision tree classifier is a supervised machine learning model that is used for both classification and regression tasks. It mimics human decision making and provides a clear and intuitive representation of data. So it is a tree-like model used for classification and regression. So what are these decision trees? A decision tree is a tree-like structure where each internal node represents a test or an attribute, each branch represents the outcome of the test, and each leaf node represents the class label or a continuous value. Um, so how does this work? Its process is that first we select a root node, that is the starting point of the tree, and then it splits, dividing a node into two or more subnodes based on certain conditions. And the decision node, when a subnode splits into further subnodes, it is called the decision node. And the leaf or terminal node, the nodes that do not split and represent an output. So advantages of these decision trees are: it is easy to interpret. The tree structure is easy to understand and interpret, even for non-experts. It handles both types of data, capable of handling both numerical and categorical data. It requires little data preparation. Unlike other models, decision trees often require less pre-processing, and the visual representation offers a clear visual representation of the decision-making process. The limitations are it is prone to overfitting, which can create complex trees that do not generalize well to unseen data, and bias with imbalanced data tends to be biased if the data has more instances of one class than the other. Instability, small changes in data can result in a completely different tree. So techniques to mitigate limitations are pruning and assembling methods and balancing data. So pruning is nothing but removing parts of the tree that do not provide additional power to classify instances. And assembling methods like using techniques like random forest or gradient boosting to improve performance and reduce overfitting. So balancing the data, techniques like resampling can help balance the data sets to prevent bias. So coming to random forest classifier, it is an ensemble learning method that combines multiple decision trees to improve the accuracy and robustness of the predictions. Each tree in the forest is trained on a random subset of the data, and the final prediction is made by aggregating the predictions of all the trees. So, the advantages of random forest are it reduces overfitting, combining multiple trees. It reduces the risk of overfitting, which is common problem in the decision trees. Handles large datasets well, efficiently handles large datasets with higher dimensionality, and the robustness offers robust performance and is less sensitive to noisy data. Well, some of the real-world applications are healthcare, finance, and e-commerce. Limitations of the random forest classifier are computationally intensive. Training multiple decision trees requires significant computational resources and time. It is less interpretable. Unlike a single decision tree, a random forest is more complex and harder to interpret.
Machine is a type of supervised learning algorithm used in a machine learning to solve classification and regression tasks. Support vector machines are particularly good at solving binary classification problems and which require the classifying the elements of a dataset into two groups. The main aim of the support vector mission algorithm is to find the best possible line or the decision boundary. So it separates the data points of different data classes. So this boundary is called as a hyperplane. And when working with a hyperplane, it in a high dimensional feature spaces. So the idea of this SVM is to maximize the margin and which is the distance between the hyperplane and the closest data points of each category. So by that it by that it will be making it easy to distinguish the data classes. The SVM are useful for analyzing complex data that can be separated by a straight line. So it is used by using a mathematical trick that transforms data into higher dimensional space. The advantages of support vector are it is effective in high dimensional spaces, robust to overfitting, and the limitations of the support vector machine is it is not suitable for very large data sets and it requires the careful tuning of hyperparameters. Neural networks it is a series of algorithms which is functioned by the human nervous system. It is used for pattern recognition and the task identification and the predictions and analyzing the complex data and solving the decision making problems. And also the neural network consists of a collection of computational units called neurons, and these units are organized in different layers and work collaboratively by connecting with each other. And the input information is transmitted through the various connections and represented by different weights to hidden layers. And ultimately, the desired output is generated. And also these neural networks are capable of recognizing patterns and complex relationships in data and also using them for a prediction and also for decision making and and for classification as well. Training a neural network involves adjusting weights and parameters to optimize its performance, and which is done by using the optimization algorithms and learning algorithms. These are widely used in various fields such as image and speech processing, and machine translation and pattern recognition, and also in a big data analysis and many artificial intelligence applications as well. So these various types of neural networks has its own structure and characteristics. And coming to the advantages of neural networks, it is capable of learning from large and complex data sets. And the limitations of neural networks are it requires substantial computational power, and it can be a black box model. And coming to the conclusion, the key takeaways we have are the machine learning significantly enhances IDS capabilities, and the proper data preprocessing and feature selection are crucial for the model performance. And the combining multiple models, which is to ensemble methods, can improve the detection accuracy. And also it continuous monitoring and updating of models are essential to adapt to new threats. Thank you.